Let me take you through the solutions to the first grade 10 math test, which is on solving linear systems. We'll solve systems using graphing, substitution, elimination, and do some application questions. Question 1, it gives you a linear system, which is made up of 2 lines, and you're asked to solve that system by graphing. To solve a system just means find where they intersect, or algebraically, find a value of x and y that satisfies both equations. If I'm going to solve by graphing, I want to get both equations into the format y equals mx plus b, so that I can use m, the slope, and b, the y-intercept, to graph them. So I have to make sure y is isolated in both equations. Notice in equation 2, y is already isolated, but in equation 1, it's not. So let me do some work with equation number 1. If I isolate y, I'll move the 4x to the other side, making it a negative 4x. And then I'll divide both sides of the equation by 5, so all the terms get divided by 5. And I'm left with the equation y equals negative 4/5 x minus 3. So the slope is negative 4 over 5, and the y-intercept, b, is negative 3. So I start by plotting the y-intercept at negative 3, and then my slope is negative 4 over 5. That's rise over run, so I go down 4, and then run 5. I can plot a point to the other side by doing the opposite, going up 4, left 5. Connect all the points with a line, and there is line 1. I also need to graph line 2 and see where they intersect. Luckily, line 2 is already in slope y-intercept form, so I know the slope is 4/5, and the y-intercept, hey, it's also at negative 3. That makes this question actually quite simple. When I plot that first point, the y-intercept, I see that's where these lines intersect. I'll plot some more points so I can graph the line accurately. So I'll use my slope, my rise over run of 4 over 5. So up 4 over 5, and then down 4, left 5. And there we have it, line 2. And if I zoom in, we can see the point of intersection is right at their y-intercept. So the solution to this system is the point 0, negative 3. Or I could write it as x value of 0 and a y value of negative 3. You could sub those values back into the equations of line 1 and line 2 and verify that that point is on both lines, therefore it's the correct solution to the equation. Part B. Line 1 is already in slope y-intercept form. The slope is the coefficient of the x, which is just negative 1. I'll write it as a fraction, negative 1 over 1. And the y-intercept is the constant after the x, which is negative 2. So I'll graph it by plotting the y-intercept at negative 2. And then my slope is negative 1 over 1. That means down 1, right 1. And points to the other side, do the opposite, up 1, left 1. Let me now figure out what the graph of line 2 looks like. I need to get that into slope y-intercept form, so I have to isolate the y. I'll start by moving the negative 2x and the negative 9 to the other side, making it a 2x plus 9. And then divide everything by 3 to get y by itself, which gives me 2/3 x, plus 9 over 3, which is 3. So my slope is 2/3, and my y-intercept is 3. Start by plotting the y-intercept at 3, and then use the slope, which is rise 2, run 3, so up 2, right 3, to plot more points. And then down 2, left 3 to get points to the other side. And if you zoom in, you can see the point of intersection is that point they share right there, which is the point negative 3, 1. So my solution to this system is x equals negative 3, y equals 1. Those two values would satisfy both equations, and graphically that's where the lines intersect. Let's move on to question 2, where we solve these linear systems by substitution. For substitution, I like to start by writing the equations beside each other. Now we have to isolate a variable. Y is already isolated in both of them. Equation 1 tells me y equals negative 6x, so I can take that negative 6x and replace the y in the other equation with negative 6x. So in equation 2, I now have negative 6x equals negative 2x plus 8. I'll get all the variable terms to the left, so I have negative 6x plus 2x equals 8. Negative 4x equals 8. If I divide both sides by negative 4, I get x equals negative 2. I can now take that answer I got for x and replace the x in equation 1 with negative 2. I know the equations are equal to each other when x is negative 2. Let's now calculate the y value when x is negative 2. So I get y equals negative 6 times negative 2, which is 12. So I know the solution to the system is the point negative 2, 12, which I could write the answer as x equals negative 2, y equals 12. Part B. Let me start by writing the equations beside each other again. Step 1 is to isolate a variable. I like to look for a variable that has a coefficient of 1 or negative 1. I notice that y has a coefficient of 1, so let's isolate that y. I'll move the negative 2x to the other side. So I have y equals positive 2x plus 9. Since equation 2 now tells me y equals 2x plus 9, I can take that 2x plus 9 and replace the y in equation 1 with that. So equation 1 now tells me that 7x plus 10 times 2x plus 9 is equal to 36. Now there's an equation with only one variable, x. We can solve for it. Distribute the 10 to get 20x plus 90. Get all the variable terms on the left. So I've got a 27x on the left and the constant terms on the right. If I bring the 90 to the right, I'll have 36 minus 90, which is just negative 54. Divide the 27 over, I get x is negative 2. So I now know the y values are equal when x is negative 2. We can calculate the y value by taking that negative 2, subbing into either original equation. It's always easiest to sub back into this one where we already have y isolated. So I know y is equal to 2 times negative 2 plus 9. So I have negative 4 plus 9, which is 5. So the solution to this system is x equals negative 2, y equals 5. Let's do one more substitution. Write the equations beside each other, and now choose a variable to isolate. This x has a coefficient of 1, so that's the one I'll isolate. I've got x equals 6 plus 3y. Take what x is equal to in equation 1, 6 plus 3y, and replace the x in the other equation with that. So I have 3 times 6 plus 3y equals 18 plus 9y. Now we just solved this equation for y. We've made their x's be equal. Now we're solving for what value of y lets that be true. Distribute the 3, and I get 18 plus 9y equals 18 plus 9y. If I get the variable terms on the left, I've got 9y minus 9y. Constant terms on the right, I've got 18 minus 18. So I have 0y equals 0. So when is that true? 0 times what is equal to 0? Well, 0 times anything is equal to 0. So once I get to this step in the equation, I know that the two lines I started with, line 1 and line 2, must actually be the exact same line. And if you notice, if you multiplied line 1 by 3, it would be exactly equal to line 2. So I know they're the same line. They're parallel and coincident. So there are an infinite number of solutions to this equation. So at this point, when you have 0 times a variable equals 0, you can stop and say infinite solutions. The lines are parallel and coincident, which just means they're the exact same line. Let's try number 3. Solve each linear system using elimination. The method of elimination, we write the equations on top of each other, and then you want either the x's or the y's in both equations to have coefficients that have the same absolute value. Notice the y's already have coefficients of the same absolute value. So then what we do is we decide will adding or subtracting the two equations from each other eliminate the variable y. Because the coefficients of the y's have opposite signs, I know that adding them will eliminate them. If we add all like terms, so add the x's first, 3x plus negative 2x is just 1x. Add the y's, 4y plus negative 4y is 0y, the y's eliminate, equals, add the constants, 4 plus 8, that's 12. So I know x equals 12. I can take that answer x equals 12 and sub it into either equation 1 or 2. I'll sub it into equation 1. So I'll sub in the x value of 12, and then I'll be able to solve for y. So I've got 4y equals 4 minus 3 times 12 is 36. So 4y equals negative 32. Divide the 4, negative 32 over 4 is negative 8. So I know the two lines would intersect at the point 12, negative 8. I can state the solution to this system as being x equals 12, y equals negative 8. Part B. Let me zoom in a bit. Notice that the x's don't have the same coefficients, the y's don't have the same coefficients. So what I'm going to do is I'm going to make the y's have the same coefficients by multiplying line 2 by 5, which I can do as long as I multiply the whole equation by 5. So I'll rewrite line 1, but I need to do 5 times line 2. So multiply all three terms by 5, which will give me 20x plus 5y equals 35. And now I need to figure out, should I add or subtract these equations? Since the coefficients of the y's have the same sign, I know that subtracting will eliminate the y's. When I subtract the x's, 3x minus 20x is negative 17x. 5y minus 5y is 0y. They eliminate. That's why we did that. And 1 minus 35 is negative 34. Isolate x by dividing the negative 17 to the other side, and I get x equals negative 34 over negative 17 is 2. Take that answer for x and sub it into either equation 1 or 2, and get the answer for y. I'll sub it into equation 2 this time. So I know x is 2, so I'll replace x with 2, and I get y equals 7 minus 8, so y equals negative 1. So the solution to this system is x equals 2, y equals negative 1. That's the one pair of x and y values that satisfy both equations. Part C. Let me actually start by rewriting both lines stacked on top of each other. But notice that line 2 is in a little bit of a different format than line 1. Line 2 has the term with a y on the right side of the equal sign. Line 1 has it on the left. To do elimination properly, I have to match up their formats. So when I rewrite line 1, I'll leave it the way it is. But for line 2, I'm going to bring that negative 3y to the other side, making it a positive 3y. And now this time, let's eliminate the x's. If I want to eliminate the x's, I'll make both of their coefficients have an absolute value of 10. That's a common multiple between 2 and 5. So I'll need to multiply equation 1 by 5. So 5 times equation 1. Multiply all three terms in equation 1 by 5, which gives me 10x minus 25y equals 10. And I'll multiply equation 2 by 2. That will give me negative 10x plus 6y equals 4. Now, because the x's, their coefficients are opposite signs, I know that adding will eliminate them. 10x plus negative 10x is 0x. When I add the y's, negative 25y plus 6y is negative 19y. And when I add the constants, 10 plus 4 is 14. So my answer for y is going to be negative 14 over 19. Let's sub that answer into equation 1 or 2 to solve for x. I'll sub into equation 1. So I've got 2x. Negative 5 times negative 14 is positive 70. So I've got 70 over 19 equals 2. So 2x equals 2 minus 70 over 19. I'm going to want to rewrite that 2 so that it has the same denominator as the 70 over 19. So I'm going to multiply top and bottom of 2 over 1 by 19 to get 38 over 19. So I have 2x equals negative 32 over 19. And then when I divide the 2, I've got x equals negative 16 over 19. So my solution to this system is x equals negative 16 over 19, y equals negative 14 over 19. Okay, those are all of the solving linear systems questions using graphing, substitution, elimination. Let's move on to more of the communication part of the test. Question 4 says, what are the different possibilities for the number of solutions to a linear system? Explain each scenario and provide a diagram. So I know for a linear system, there could be one solution, and that happens if the lines have different slopes. So I'll just draw two lines with different slopes and show that they intersect at a single point. There could also be no solutions if the lines have the same slope, but different intercepts. And we say that those lines are parallel and distinct. So I'll just draw a picture of two lines that are parallel and distinct. These two lines would never cross. And the last scenario is an infinite number of solutions. And that happens if the slopes and intercepts are the same. So we say the lines are parallel and coincident. So I'll try and draw two lines that are on top of each other. So notice they're the exact same line. They intersect at an infinite number of points because they share all the points that are on each line. Question 5 says, analyze the solution to this linear system. The method of substitution was used. Is it correct? If so, how does the check prove that? Is it wrong? What was done wrong? And is there a problem with the check? So let me just look through what the person did for this method. So they've got the lines written side by side. I noticed that y is already isolated in equation 1. And it says they then subbed 3x minus 2 in for y into the other equation. And we have this line here where that happened. But I do see a mistake with this line. When 3x minus 2 was subbed in for this y, it wasn't put in brackets. So we're not subtracting the whole y value. What should have happened was when it was subbed in, it should have been put in brackets so that we're subtracting the entire y value, which would mean the next line would be 4x minus 3x, which, yes, is x, but then minus negative 2, so there should be a plus 2. So for that reason, I know they're going to be getting the wrong answer. It should actually be negative 5, not plus 2, but minus 2. So not negative 3, but negative 7. And then after they solved x is negative 3, it says they subbed x equals negative 3 back into line 1. And it looks like they did that properly, getting negative 9 minus 2, which is negative 11. But they should have actually subbed in negative 7. So it would be 3 times negative 7, which is negative 21, minus 2, which is negative 23. So I've corrected this for them. The correct solution is actually negative 7, negative 23. So let's look at how they checked the solution. And they seem to think that their check verifies the solution of negative 3, negative 11. But I see why. They only subbed negative 3, negative 11 into line 1, right? Line 1, the left side is y, the right side is 3x minus 2. That comes from line 1. So all they did by proving that negative 3, negative 11 makes left side equal right side in line 1, all they did was prove that negative 3, negative 11 is on line 1. They didn't prove that it's also on line 2. So this alone is only half of the check. What they should have done is they should have also checked in line 2. And if they checked in line 2, the left side of line 2 is 4x minus y, and the right side is negative 5. So if we sub the solution in, 4 times negative 3 minus negative 11, I get negative 12 plus 11, which is negative 1. Notice the left and right sides are not equal. What does that mean? That means that negative 3, negative 11 is not on line 2. So negative 3, negative 11 can't be the answer to this linear system. Yes, that point is on line 1, but it's not on line 2. So that means those lines could not intersect there. So if I were to summarize the mistakes, when initially substituting 3x minus 2 in for y, it was not put into brackets. That resulted in an incorrect answer for x. Second mistake, only check the answer in one line, when for linear systems you have to check it in both lines. All right, let's move on. The last part of this test is the application section. In each of these application questions, we're going to model the scenario with two equations. In each of those two equations, there will be the two variables that we're trying to solve for in the question. I'm going to spend most of the time here trying to help you set up the equations, and then I'll very quickly show you how to solve the linear system. Part A says George invested $2,000 in two accounts. After 1 year, one account earned 4.5%, and another account lost 2% of its value. Fortunately, he still had a net gain of $38. How much money was invested in each account? So the first thing for these questions that I like to do is define the two variables that we're trying to solve for. I want to know how much money was invested in the account that earned 4.5%. I'll call that X. And I also want to know the amount he invested in the account that lost 2%. Now that I've defined my variables, I need to make two equations where each of those two equations involve those two variables. My first equation, I know that he invested a total of $2,000. So if I add up the amount he invested in X plus the amount he invested in Y, I know that should equal 2,000. There's my first equation. My second equation will involve the interest that was earned. Well, if I find 4.5% of X, so 4.5% of what he invested in account X, I'll do 0.045 of X to find that. If I then subtract 2% of what he invested in Y, right, I need to subtract because he lost 2% of what he invested in Y, so I have to subtract 2% of Y, so do 0.02 times Y to calculate that. I know if I do this, 4.5% of X minus 2% of Y, that's going to give me his net profit of $38. Now that I have my two equations, it's just a matter of solving this linear system. And you could do that using either substitution or elimination. I'll just quickly use elimination. You can follow along as I do the solution. So you can see from my solution that he invested $1,200 in the account that earned 4.5%, and invested $800 in the account that lost 2%. I'm going to move this solution out of the way and we'll do the next question. Part B, it says Martha mixes cream that is 10% fat with cream that is 2% fat to make 30 milliliters of cream that is 5% fat for her morning coffee. How many milliliters of each type of creamer does she mix together? So I have two unknowns again. I need to know X, which I'll say is the amount of 10% cream used, and Y, which is the amount of 2% cream used. Now I need to make two equations that involve these two variables so that I can solve for each of them. My first equation is going to be about the total volume of the mixture. I know that however much of the 10% plus however much of the 2%, it's supposed to make a 30 milliliter mixture. So I know that X plus Y is equal to 30. My next equation is going to have to do with what percent of the mixture is made up of fat. If I want to know how much fat is in this mixture, well, I know 10% of creamer X, so 0.1 times X, plus 2% of creamer Y, so 0.02 times Y, will give me the total amount of fat in the mixture. And I know I want 5% of the 30 milliliters to be fat. So I'd have to do 0.05 times 30 to figure out how much fat is in my final mixture. And 0.05 times 30 is 1.5. So I'll just erase that and write 1.5 instead. And now once again, I can solve this using substitution or elimination. You can follow along as I do that. So you can see from my final answer that Martha used 11.25 milliliters of the 10% creamer and 18.75 milliliters of the 2% creamer to make that 30 milliliter mixture that is 5% fat. Let me move this answer out of the way and we'll do another one. Part C says a canoe makes a round trip from campsite A to B, which are 10 kilometers apart. The upstream trip takes 40 minutes and the downstream trip takes 25 minutes. What is the speed of the canoe in still water and what is the speed of the current? So it pretty much tells me what my two variables are. X is the speed of the boat in still water, and Y is the speed of the current. Now, notice there is information given about speed, distance, and time. Hopefully you remember the relationship between those variables. The relationship we'll be using is that distance is equal to speed multiplied by time. I'll make an equation that follows that relationship for the upstream trip, which means against the current, and also for the downstream trip, which means with the current. For the upstream trip, well, the distance traveled is 10 kilometers. The speed, well, if they're traveling upstream, the speed that the boat is going will be the speed it can go in still water minus the speed of the current, right? The current is going against the boat, so it's going to slow it down. So my speed in the upstream trip is going to be X minus Y. And I know that takes 40 minutes, so I'll multiply that by 40. I suppose I could simplify this equation a little bit by distributing the 40 to the x and the negative y to get 40x minus 40y. There's equation 1. Equation 2, I'll make from the information about the downstream trip. The distance is still 10 kilometers, but because it's downstream, the speed the boat will be going is the speed it can do in still water plus the speed of the current, right? The current will be helping the speed of the boat. So x plus y is the new speed. And the time, it takes less time, right? Because the current is helping, it only takes 25 minutes to do that same distance. If we simplify this, I have 10 equals 25x plus 25y. So we have two equations. Now what we have to do is solve the system using substitution or elimination. I'll do that quickly. So you can see from my solution that I got my speed of the boat in still water to be 0.325, and the units we're in is in kilometers per minute. And the speed of the current is 0.075 kilometers per minute. If we wanted to change these to kilometers per hour values, we can just multiply those answers by 60, but I'll just leave them like this for now. Okay, let me move this answer out of the way and we'll do our last question. The last question says a bag contains 1,234 coins. All the coins are either quarters or dimes. The total value of the coins is $290.05. How many of each type of coin are there? So we want to know two things. I'll make X the number of quarters and Y the number of dimes. And now I need to figure out is how can I solve for these two things? To solve for two variables, we'll have to make two equations. The first equation I can make from the fact that the bag contains 1,234 coins. So I know the number of quarters plus the number of dimes, x plus y, is going to be equal to 1234. The second equation, I can use the fact that the total value of the coins is $290.05. I know the value of 1 quarter and 1 dime, so I can use that to make an equation that gets us that final total value. Each quarter is 25 cents, so I can do 0.25 times x, plus each dime is 10 cents, so 0.1 times y. If I do that calculation, that will give me the total value of all of the coins that are in the bag, which is $290.05. There's my second equation. And I'll solve this using elimination again. And there you have it. You can see from my final answer that there are 1,111 quarters and 123 dimes in the bag. I'll quickly scroll through all of the answers to the application questions just in case you missed any of them. Feel free to pause and take a look. And that's the end of the test. Jensen